Welcome back, dear students. In this video, I am going to discuss addressing modes and instruction set of 8051. Recall that in previous video, I have discussed architecture of 8051, features of 8051 and pin details of 8051. Our intention is to master the assembly language programming with 8051. So in today's session, I am going to discuss initially what are the default values of resistor after reset. Because we have seen the architecture, even we have seen, say in previous video, we have seen RAM and ROM and other general purpose resistors apart from special purpose resistors. Now, so whenever a microcontroller is reset, some of the resistors will be having a default values. To master the assembly language programming, even it is necessary to know and remember the default values of those resistors. Okay, so this is the list of the resistors whose default values have been given in the second column. The first column here is a resistor and the second column here is the default value. Say all the default values have been given in a hexadecimal number. Okay, if we see here PC, which stands for program counter, it's a default value. Whenever the microcontroller will be reset, it will be loaded with say 0000. So means it will going to address the first memory location of the code memory. Okay, say the accumulator will be having 00, even B resistor will be having 00. SP, which stands for stack pointer, it will be loaded with 07, and PSW, program status word, will be having 00. This is the reason. Look at this. The PSW will be having 00 means all the bits in PSW will be 00. That means even RS0 and RS1 will be 00. And recall that in previous video I have told whenever RS1 and RS0 are 00, by default say it is going to select bank 0. That's the reason when there is a reset, the because PSW will become 00, even RS0 and RS1 will become 00. That's the reason bank 0 will be always active whenever we reset the microcontroller. And IP, which stands for interrupt priority, which will be 00. IE stands for interrupt enable. Say the content will be 00. SBUF, it is unpredictable. Basically SBUF, there will be two resistors. One is for receiving and another one is for transmitting. But both the resistors will be unpredictable. We cannot predict what will be the content. Say SCON, serial control resistor. PCON, power control resistor. TMOD, power mode selection resistors. TCON, timer control resistors. All these resistors will be 00. Apart from that, TL0, TH0, TL1 and TH1, these are timer resistors for two timers, timer 1 and timer 2, so whose contents will be 00. And there is a 16-bit data pointer which I discussed in previous video. So, and it can be divided into two 8-bit resistors. One is DPH and another one is DPL. So the DPH will be 00 and even DPL will be 00. The content of DPL. And afterwards there are 4 ports: port 0, port 1, port 2 and port 3. Whenever the power is reset, these ports bits will be FF. So it means all the ports will be set to a FF in hexadecimal. And in previous video even we have discussed the resistor and their addresses also. Okay, so remember these things which will going to help us while doing the assembly language programming. So with this I'll move on to discussion of addressing modes. Okay, so what is addressing mode? Consider that I have taken class. Inside the class all students are there, and I want to know the name of a particular student. I know the roll number but I don't know the name. There are so many ways to get the name. Like say for example, so I can ask the student immediately there itself. Say like what's your name, so that fellow will answer with his or her name. And say for example, if I have a student register in my table, I can just open the register and I can see roll number and against that name. Otherwise I can ask some other student about that roll number and get the name. Okay, there are so many ways. I'm interested to know the name. The name is a data. I want to get that data. But there are so many ways to get that data. The addressing mode is that itself. The way of fetching data, or also called as operand, is called addressing mode. So operand or data, so both one and same. Previous video I have told operand is nothing but it's a data on which any operations will be performed. Okay, so there are so many different ways of fetching a data. In 8051, basically there are 5 different addressing modes: immediate addressing, direct addressing, resistor addressing, resistor indirect addressing, and lastly indexed addressing mode. So now we are going to see one by one these addressing modes in detail. The first one is immediate addressing. The name immediate indicates that the data is immediately stored in a memory after the opcode. Remember, these opcodes will be stored. Any opcodes, whenever we write a program, those opcodes will be stored in a code memory. And even, so as the name here indicates, immediate, this particular data, it will be stored in a code memory only just after the opcode. For every instruction, there will be a operation code, which in short it's called as a opcode. That those opcodes will be stored in a code memory, and along with the opcode, even the data on which that operation code will work, it will be stored next to the opcode. Because of that, it is called as a immediate addressing mode. The data will be either 8-bit or 16-bits in long. Okay, the syntax for this addressing mode is something like this. Here mnemonic move resistor, any resistor from R0 to R7, or general purpose resistors, that is R0 to R7, or even accumulator or DPTR can be used here, and this is a data. So remember, here hash indicates immediate data. Some of the examples are like move R0 comma hash 20h, here move accumulator comma hash 20, and here move DPTR comma hash 0f00h. So look at this. This 30 indicates a decimal number. Here 20h indicates hexadecimal number. Here even 0f00h indicates hexadecimal number. So we can move either decimal number or hexadecimal number, or even a binary number. If at all we want to move some binary number, we can write like move a comma 100111001, and at the end we write b, where b stands for a binary data. Okay, these are different examples, and here keep this in mind. The symbol hash is used to indicate that the operand is a data, which is not an address, because if this hash symbol is removed, it will become a direct addressing mode, which we are going to discuss shortly. Okay, here I hope this why we call this particular addressing mode as immediate addressing mode is clear to you. So the simple thing, when we write a program, the program will be, during assembling, the program will be converted to a opcodes, and that opcode means it will be converted to hexadecimal code, where the mnemonics will be converted to opcode, and immediately after the opcode, if the data is stored, such remember, the data or operand will be used to operate, means it will be used for the operation, and operation will be there above and its opcode is there below. Because there itself in a code memory the data is available, this type of addressing is called as immediate addressing. The next addressing mode is direct addressing. So in this addressing, a direct address of a memory location is provided in the instruction to fetch the operand. See, inside the RAM we have a different areas. Even the whole RAM, right from memory location 00 to 7F, 128 bytes of RAM can be accessed, and apart from that, even special function registers can be accessed using this direct addressing mode. Here, direct address of a memory location is provided in the instruction to fetch the operand. Using this addressing mode, it is possible to fetch the operands stored only in either internal memory or SFR. We cannot access data or operand that is stored in an external RAM. So keep this in mind. We can only access the data or operand that is stored in either internal memory or special function registers. So some of the examples are like move a comma 10h. Here remember 10h indicates it's a direct address. So this is what the difference. In immediate addressing there was a hash symbol, but here there is no hash symbol. So it indicates that it's a direct address, means whatever the address it is provided, it's a direct address. The meaning here is move the content of this memory location, 10h memory location, into the accumulator. Whereas the meaning in case of immediate addressing is move this data in this register. This is the meaning here. So this data is available here itself. Means the same data will be this data itself. Like say 20H itself will be moved to R0. Here 30H itself will be moved to accumulator. This is in case of immediate addressing mode. Whereas in case of direct addressing mode, go to 10H. Means go to memory location 10H, fetch the data and store in accumulator. Say here 10H is a address. It is not a data. Say here. One more thing is, this is also, see, take the content of resistor Rn. N will be either anywhere between 0 to 7, any resistor like R0, and store it in a memory location 20H. That's the meaning. Here direct address is given in a source position, whereas here the direct address is given in a destination position. Means the content of R0 to R7 in general Rn will be stored in a memory location 20H. And here, say this is move 30H comma hash is 05. Look at this. This is immediate data which will be stored in a 30H memory location. This is a immediate data. 05 is a immediate data. This is stored in a 30H memory location. Means even this can be considered a immediate addressing because this particular data is immediate data, but it will be stored in a 30H memory location. Because of that, even you can consider this as a direct addressing. And here, so very important thing is, even we can move, say the content of one memory location, internal RAM memory location, to the another internal RAM location just by using the addresses. Like here, move 30H comma 3FH. The meaning is move the content of 3F memory location to a 30H memory location. Okay, so using this addressing, it is possible to move the data directly between two internal memory locations, something like this. Okay, so the direct addressing means, so you need to remember that here the address, directly the address of the internal RAM or SFR will be given. So SFR is like, say for example, for a accumulator, instead of writing A here, we can write its address. So accumulator address is 0E0H. So we can write this as like say move 0E0H comma R0 R1, something like that. Okay, so or any other immediate data or even the content of some direct address. We can use, in case of direct addressing, we can use either internal memory or any SFRs. With this, we'll move on to say address of special function resistors. Okay, so these are SFR. This is address. Okay, so the A will be having a address 0E0. B will be having, A is nothing but accumulator. B resistor whose address is 0F0. DPH address is 82. DPL is 83. Interrupt enable is 0A8. Interrupt priority is 0B8. P0 to P3 80, 90, A0, B0. PCON is 87. PSW is D0. SBUF is 99. SCON is 98. Stack pointer is 81. TCON, TMOD 88, 89. TH0, TL0, TL1, TH1, TL1, 8C, 8A, 8D, 8B. So these are all special function resistor and say their direct addresses. Say all the direct addresses have been given in hexadecimal number. And one thing you note it here, if the hexadecimal number, if it starts with other than 0 to 9, say we are supposed to write 0 here, keep this in mind. 82 has been written directly, 83 has been written directly, but A8 has been written with 0, means 0A8. Otherwise, if we don't write 0 here, say in case of writing a program, say this A8 will be considered as a symbol, not as a number. That we are going to discuss once we start the assembly language programming. So there is much more to discuss for the first program, which I am going to discuss later. Okay, so as on now you remember, whenever we are going to write a hexadecimal number, if the digit starts with other than 0 to 9, then say you should write that digit with 0, like 0F0 or 0A0, 0B0. Hope this is clear to you. So remember addresses of these special function resistors, which will going to help us in writing assembly language programming. Right. So with this we'll move on to the next addressing, that is resistor addressing mode. In this addressing mode, the source or destination operand will be present in resistors like Rn, in general R0 to R7. Means resistor to resistor transfer will takes place. Okay. So example is something like this. Move A comma R0 or move R6 comma A. But one thing here is the size of both source and destination resistor should be same. Okay, so here I cannot write move dptr comma r0 because dptr cannot be used. So important thing is in this addressing mode the data transfer can take place between Rn resistor and accumulator. Any of the Rn resistor and accumulator. And one more important thing is that the data transfer cannot be done between Rn resistors. Means I cannot write move say R0 comma R1. That is not allowed. Okay, say move R0 comma R1 is not allowed. So that is very much important. If at all you want to move the content of R1 to R0, say for that purpose we can use a direct addressing. Like say move the address of R0 will be 00 in bank 0 and address of R1 will be 01. We can write it as if at all I want to move the content of R1 to R0, I can write move 00 comma 01. Which indicates that say move the content of our memory location 01 to a memory location 00. Okay, whereas we cannot move the means we cannot transfer the data between Rn resistors. We can transfer the data between Rn resistor and accumulator, not in between Rn resistors. Okay, by default the resistor bank 0 will be active. To use resistors from other bank, one should make use of RS1 and RS0 bits of PSW, which I have already discussed in previous video. If other than Rn resistors and accumulators are used, the assembler will use such resistors direct address in instructions, as in case of move B comma A. So here you may consider this as a resistor addressing mode, but basically it will become a direct addressing mode because here to perform this operation B's direct address will be used. The B's direct address is 0F0. So this the assembler will going to treat this as a move 0F0H comma accumulator. Okay, so means if other than Rn resistors and accumulator, if we use any other resistor, assembler will use address of such resistors and perform the operation. Okay, so this is a resistor addressing mode. And the next one is resistor indirect addressing mode. In this addressing mode, the address of a memory location is indirectly provided by a resistor. In case of direct addressing mode, which we have discussed, here directly the address is given, like move A comma 10H, go to 10H memory location, fetch the data and store in accumulator. Like here, say take the content of resistor Rn, go to a memory location 20H and store there. That's the meaning. Means directly the address has been given. Whereas in case of resistor indirect addressing mode, the direct address will not be given. Instead, the address of memory location is indirectly provided by resistor. The @ symbol is used to indicate the presence of address in a resistor. The operand can be fetched by using the address present in the resistor. Like say example, if I write here move A comma at R0 or say move X at R1 comma A, say move X A comma at DPTR. So look at this here, at indicates so R0 is resistor, R1 is resistor, whereas here the at symbol indicates it's a indirect addressing, resistor indirect addressing, also called as, in short it is indirect addressing. So here we cannot use any other resistors other than R0, R1 for internal or external memory transfer of 8-bit, and if at all I want to transfer to external memory, say which can be of 16-bit, then we can use a DPTR. R0, R1 resistors can be used for 8-bit address and DPTR can be used for 16-bit address, and 16-bit address will be say external to say that to RAM address, it will be external to 8051 microcontroller. No other resistor can be used, very important thing, no other resistors can be used other than R0, R1 and DPTR. So normally to say move any data indirectly inside the internal memory, we can use R0 and R1. If the address is 8-bit external to a microcontroller, even then we can use R0 and R1, but the instruction there will be MOVX. MOVX indicates move to external RAM. So here move indicates by default internal RAM. Okay, so here by default the DPTR will be MOVX because say the DPTR will give us 16-bit address and that address will be taken and the content of that external memory. So the meaning here is, look at this, go to a resistor R0, fetch the address, go to that address, fetch the data and store in accumulator. Very important. At R0 means whatever is the content of R0. Like say for example, if content of R0 is 10H, at R0 means here 10H, means this instruction you can treat later as a move A comma 10H. Nothing but 10H is a address. Go to that address, fetch the content and store in accumulator. Here move X at R1 comma A. Say go to the fetch the content of accumulator, go to the resistor R1, take the address and go to that address, store the content of accumulator in that address. Means here address is given indirectly by the resistor R1, and because of this X, it indicates that address is a external to a 8051, not internal RAM. Instead it is a external RAM. Hope this addressing mode is clear to all of you. So very important thing is, in case of resistor indirect addressing mode, the resistor itself, either R0 or R1 or DPTR, say they will going to specify the address. Say if at all we want the operand, we should go to that address and fetch the data and store in accumulator. Okay, this is how the resistor indirect addressing is going to work. Right. So with this, we'll move on to the last addressing mode, which is called as indexed addressing mode. So this is a very typical addressing mode. Try to understand this. In this addressing mode, the effective address of the operand can be obtained by adding the content of a base resistor and an offset resistor. Okay, there will be two resistors here. The content of one is called as a base resistor and another one is called as a offset resistor. The content of base resistor and offset resistor both will be added to get the effective address of the operand. Okay, the base resistor can be either DPTR or program counter. So remember, even program counter content can be used in this addressing. Okay, the base resistor, it can be either DPTR or program counter, while the offset resistor will only be accumulator. Like say for example, this is the instruction which will be used. Remember, this indexed addressing mode will work only with the code memory. Okay, for that purpose, to indicate code memory, say the mnemonic here is move C. Move C A comma at A plus DPTR. Or one more instruction we get with PC is move C A comma at A plus PC. So what is the meaning of this? Here, the C in move C instruction refers to code memory. This addressing mode is basically used for accessing the data from a lookup table stored in a code memory. What is this lookup table, where it is useful, that we are going to discuss next coming videos. So lookup table is something like, say I have stored a data inside the code memory. So much data, if the data content is much, I cannot store that in a internal RAM. Such data will be stored in a code memory itself. How to store such data in a code memory, that also we'll discuss later. So if at all I want to fetch the content of the code memory itself, we can use this addressing. Okay, so the meaning here is add the content of accumulator and DPTR to get the address and go to that address, fetch the data, store in accumulator itself. And here is add the content of PC and accumulator, whatever the total address we get, go to that address, fetch the data and store in accumulator. Okay, here if at all we increase accumulator every time, the DPTR will become a base resistor and accumulator will become a offset. Means from this address how many bytes I should go. That's the meaning. So more about this anyhow, say when we are going to write assembly language programs, we are going to discuss. And even in case of instruction, while studying instruction, you read more about these instructions. Say still, if you get any difficulties, you can ask me so that I can say explain these in my next videos. Right? Say these are, we have discussed 5 addressing modes, namely immediate addressing mode, direct addressing mode, resistor addressing mode, resistor indirect addressing mode, and indexed addressing mode. So very important. So the addressing mode is nothing but a way of fetching a data or operand. Okay, so these 5 addressing mode you should remember, and whenever say any instruction will be studied, so you should apply these addressing mode to those instructions. Which are all the addressing mode supported by that instruction you should study. Okay, so with this I'll move on to the next part, which is nothing but instructions of 8051. What I'm going to do, I'm going to just tell the different classifications of instruction, and I'll tell you how to study those instructions. The instructions set of 8051, microcontroller 8051 can be divided into following groups. Basically, all the instructions can be categorized into these groups. One group is data transfer instructions. These are the instructions which will help in transferring the data. either between resistor to resistor or between resistor to memory locations or memory location to memory location, anything. To transfer the data between say memory location or say resistors, this type of instructions are used. Means the type of instruction which are used to transfer the data, say all those instructions can be called as data transfer instructions. And some instructions which are used for arithmetic operations like for subtraction, addition, multiplication, division, such instructions are called as arithmetic instructions. Logical boolean instructions, the instructions which will perform a logical or boolean operations like say ORing, ANDing operation, then complement operations. Such operations, if the instructions are doing such operations, such instructions are grouped in logical or boolean instructions. Okay, and branch or jump instructions, these instructions will help us to jump to some other say instructions while executing. So means there are even different types of jump instructions. So while studying, say you are supposed to study say all different types of jump instructions properly. Basically there are three types of jump. One is relative jump, the second one is absolute jump, and the third one is long jump. All different types of jump instructions you are supposed to study. Even say call instructions also you can study in this particular branch. And the last one is bit manipulation instructions. If a instruction is manipulating just a bit, like set bit and clear instructions, which will going to manipulate a bit. So if we are working on a bits of any memory location or a resistor, just a single bit, then such instructions are called as bit manipulation instructions. Okay, so these are different categories of instructions which you are supposed to study. So how to study these instructions, I'll tell you. Just knowing an instruction what it does is not enough. Remember, dear students, say most of the time when I tell the student to study the instructions, they'll just study that okay, move a comma b is it will going to move the content of b to a. Otherwise add a comma r0 means it will add the content of r0 to accumulator. That is not enough. To become good at assembly language programming, say just knowing the say instruction what it does is not enough. There are some other points those needs to be considered. Like say for example, first and foremost thing is the total description of the instruction, what it does, and the second one is addressing modes supported by the instructions. So which are all the addressing modes supported by that instruction. If the instruction move is there, say using move all the addressing modes you are supposed to write. If there is an instruction called add, using add you are supposed to you should be able to write all the addressing modes. That's the second thing. And the third thing is flags. As per the PSW means program status word, which are all the flags affected after execution of that particular instruction. Very important. And the last one is the size of instruction in bytes. How many bytes a particular instruction will take. Before starting to write a program, study all the instructions as per these points, so that once we start writing a assembly language program, you will be thorough. Just one example, I'll tell you how to study the say instruction. Say for example, if the instruction is add a comma operand, okay, here say what kind of operation it performs. Any more description you can write. Say you just study you can study. Say here I'm telling in short, it is going to add a byte to accumulator. Whatever the byte the operand will give, that byte will be say added to accumulator. Means the result later it will be stored in accumulator. The total description of this will be studied. And flags affected, say remember which are all the flags affected. Carry flag, auxiliary carry flag, overflow flag, and parity flag. Means after say executing these instructions, all these flags will be affected. And which are all the addressing modes supported. Look at this. Add a hash data, this is immediate addressing mode. Number of bytes 2, because 1 byte for this and another byte for mnemonic. Okay, so add a comma r5, this is register addressing mode. The size or the number of bytes 1 byte. So add a comma ADDR, this ADDR is a direct address of an internal RAM. So means this is a direct addressing mode, 2 bytes. And one more is add a comma at RI, where RI will be say either R0 or R1. Say index register. So this register indirect addressing mode. So this is going to take a 1 byte. Whenever you are going to study any instruction, you study all those instructions, consider these points in mind. So with this I'll stop today, and in a next class I'm going to discuss 8051 assembly level programming. Okay, so basically how the assembly level programming will be written, say that I'm going to discuss. The steps in executing assembly language programming will be discussed in next session. So with this I'll stop today. Thank you for watching.